let's start here. The big thing that I do say it's been about 15, 20 years now, is something called sabermetrics. People know the term, people don't know the term, but it's essentially baseball science. And I know this is a science, technology, informatics group, and so this will be about baseball specifically, but it really applies to sports in general. There is this emerging career that many people may be thinking of, which is sports analytics as a career. Just to frame that quickly, in 2004, when I first taught my class in sabermetrics and baseball analytics, in baseball analysis, there were probably, depending on how you define it, there are probably about 15 to 20 people working in baseball with a full-time job thinking about baseball analytics, doing the work of looking at data to try to better understand the game. Since then, the number is probably about 500 now. So that's context. That's an order of magnitude change in the number of people employed just in baseball. But the corollary to that is that every other sport has blown up completely, from virtually zero professional full-time analysts to hundreds and hundreds. So this is a career now. This is actually a field that's emerged over my career as an instructor teaching this material. And this is baseball. You have to start with baseball here. Let me frame this whole conversation between all of us with a really important start, which is I hate, this is not a brag. This is just like any of us could talk about what we know. I know this material very well. I can talk all day about it if you like. I've got about 40 album sides of discussion around this material. It's probably much more interesting for you as individuals to ask me questions. If this was an interactive discussion, I think I'd serve you better. I've organized this material to try to frame baseball analytics in a way that I think you can learn from, but I really want to encourage you to interrupt, ask questions, wonder about things. So let's go through this a little bit. This is sort of where I like to start because it really frames baseball and what's going on. This is the first step here. Oops, we're not seeing, there it is. So this is what one of the GIFs I showed earlier, or GIF, depending, I don't want to debate it. So this is a pitcher throwing 6 different pitches. That's the first function in any baseball event. The pitcher and catcher and maybe the coach decide what to throw, and they try to execute it. So this is showing this pitcher has 6 different pitches, and you can appreciate potentially, or is it 5? It's 5, sorry. You can appreciate the different kinds of pitches that are going on here. They bend different ways, and this is physics. This is basic physics. It has a lot to do with the Bernoulli effect, the Magnus effect. It's what a pitcher's doing in their grip and their spin to move the balls in different directions during the throw. You see a 12-6 throw, a ball that drops down. There's another ball that's actually rising. It's not rising above gravity, but it's moving upwards on the Magnus effect. You see balls go left, right. You got balls going left and right by the pitcher. You got balls going up and down by the pitcher, and various parts of the whole circle is managed by the pitcher. This is the first event. The second event is the batter. Now, this is a batter who's hit home runs on each of these pitches. And the GIF here is to explain the batter's job after the pitcher's job of trying to locate the pitch they want to throw. The batter's job is to take that location and then hit it hard and hit it far and hit it well. So the purpose of this GIF is to show you that Miguel Cabrera can cover the plate. These are 6 different pitches. They're at different locations, and he has the ability to hit each of them really far to help win a baseball game. So now you have the pitcher's job, the batter's job, and then I just go here because this is one of my favorite moments in baseball. This is the best hitter of our generation, and we can debate that if you want. I think it's demonstrably clear and obvious that Barry Bonds is the best hitter I've ever seen with my own eyes. And this is Barry Bonds. And this is Barry Bonds in the bottom of the ninth with 2 outs and the bases loaded, getting intentionally walked. This is an incredible event in baseball. Okay, if you're a baseball fan, maybe you understand this. And you can see Barry Bonds' face. He's looking at the catcher going, what? The bases are loaded. You're walking in a run. You're going to give up a run here so you don't pitch to me? He's looking like, what are you doing? Well, this has happened, I think, just once in all of baseball. This event right here that's captured on this GIF. The Diamondbacks decided, hey, we should do this. Now, I'm going to make the claim that this also is baseball science. This is my quick introduction to myself. I've had the privilege of teaching at Tufts, Harvard, and BU baseball analytics, Sabermetrics. It started at Tufts, and it was a seminar format. I just taught, in a small seminar room, small classroom. It was very good in that format. BU decided to make a MOOC. If you don't know what a MOOC is, it's a very large course online that these terms now are, these terms weren't common when I did the MOOC, but it's called asynchronous learning is really what the buzzword is now. Because of COVID and the way instruction is going in different ways, different places, asynchronous learning is actually a term that most of you have probably heard already. It wasn't a term people thought of much 4 or 5 years ago when I designed and put together the MOOC. The MOOC is this large format. We've had, I think the number's up to 60,000 people register for the class. And we've had, I think, up to about 4,000 people finish the class. But it just sits there like an archive at edX, which is an MIT Harvard MOOC platform. So we taught Sabermetrics 101. BU funded it, paid for it, gave me a little leave to put it together. It's essentially a baseball analytics textbook. So anyone in this chat here can freely go to edX, sign up for it, and learn the fundamentals, the basics, the 101 of baseball analytics. Then I taught it at Harvard in their extension school, which is, this is 2 years ago, so I was able to teach in person, synchronously on Zoom, and asynchronously recorded for other students to do. So, if anyone here is still currently on the faculty or instructing and teaching courses, you're having discussions on how to teach in September with your colleagues and your faculty. And trust me, I've been, because I had so much experience teaching this already, I've become like a resource for a lot of friends and colleagues on how to get this done. How do we teach now in this format? The bottom line is I've had the privilege of designing and teaching this class in many different formats at Tufts, Harvard, and BU. And it's been the defining sort of arc of my career from a bench biologist. I was trained as a neuromuscular physiologist. Now I consider myself a baseball analyst, data scientist. There's lots of different terms. So that's who I am. But I like this quote from a friend named Sig Mayhall from the Orioles. Interestingly, Sig Mayhall left the Astros right after 2017. He decided he was going to get out of there. He never has given a quote why he left. People were wondering, but I think people have a better sense now about why he left in 2017. But he has this quote here. And this is an important quote about science, being a trained scientist, being a group of scientists. Hopefully, this is important. I believe this quote, and I think Sig is right. If we can sense it, we can quantify it. If we can quantify it, we can learn about it, meaning we can study it, and then it's science. So, excuse me. My next favorite quote to start talks is the general manager of the Paris Liberty, Voltaire, And this is probably one of the most important quotes I teach with, I give to my students. And it just frames a lot here, okay? So if you wish to converse with me, define your terms. And I think that's really crucial. Always define what you mean. So when I talk about science, and this is pretty obvious here, I want to make sure that we understand a big part of science is observation. And you can have an observational science like astronomy. You can have an observational science like sabermetrics. There's plenty of ways to think about science and science as a field through empiricism, through just observing, sensing it, and then trying to understand it better. You can't always do experiments. That's a huge part of science, obviously, but so is really thorough observation. And so I start there because I always make the argument that baseball is a science, that I've been trained in science over my training, and then I'm an instructor in a university in science, and so my career has been as a scientist. But you know, baseball, excuse me, baseball science is what I do now. It's what my research life is. It's what a big part of my teaching life is baseball science. So this group may or may not be hard to convince, but I start always trying to sell the idea that baseball is a science, just like biology, physics, natural sciences that you can see. But here's the definition, and you always want to start here. The scientific and objective analysis of baseball is what sabermetrics means. And that's a key term. It captures, this term, coined by Bill James, captures the sense of this new field that I've described as really emerging. Any questions so far while I try to get rid of my frog in my throat here?
Why is it called sabermetrics?
Good question. There's something called the Society of American Baseball Research, and the acronym is SABR. Okay, so Bill James just put, you know, those two things together, metrics and SABR, and called it sabermetrics.
Yeah. Andy, does this apply to other sports as well as baseball?
Absolutely, yes. Yeah, the broad umbrella term now is sports analytics, as opposed to sabermetrics, which is rooted from baseball. But sports analytics, this broad field analyzing all different kinds of sports, very meticulously, scientifically. It's going in the NFL, the NHL, the NBA, Major League Baseball, but the biggest place in the world where it's happening is professional soccer. Professional soccer clubs all over the world are hiring analysts to analyze football, you know, real football, not American football. And so the careers there are just exploding because teams have found out, led by Liverpool. And if you know, Liverpool is owned by the Fenway Sports Group, which is the Red Sox ownership. So the Liverpool team was at the forefront of football analytics, and that just exploded. So an umbrella term instead of sabermetrics these days would be sports analytics, and you could specify it by baseball analytics, football analytics, American football analytics, a lot of different ways.
How would you compare and contrast this to Moneyball?
Moneyball is Michael Lewis is a great writer. If you don't read Michael Lewis, you should if you have the time. It is his treatment of the Oakland A's and the market inefficiencies 20 years ago available in baseball analytics is a great read. And the movie does a pretty good job capturing that. It really is, Michael Lewis has a theme in his writing around market inefficiencies. It started when he was young in his 20s, when he worked in finance. But he looks at the market inefficiencies in the game of baseball. It became the book Moneyball, became the movie Moneyball. And yeah, so this is Moneyball. Moneyball describes this sort of field of trying to understand a game better through observation, very thorough observation, data collection to try to really find an advantage in the game so that you can actually help your team win. And it actually is a career. I mean, it doesn't, 20 years ago, it really wasn't a career. But now people study this to try to get jobs in this. And so it's very interesting.
And does it work?
Yes. Well, I mean, the work, yes. You can find these bits of information that can drive decision-making that can help your performance. This is data science, right? Mm-hmm. So if you run an oil company, you can probably be very thorough in your analysis of an oil rig and how it works. And once you thoroughly observe it and analyze it and get down to some data collection, you can actually determine, oh, if I did this, it would save money or do something to help me win. So it's no different here. You in all sports, you're able to find these small, slight advantages that usually only last, like any market, they kind of only last for a little bit, then they get closed. In other words, the other teams adopt them. And once the group that's competing in this, either the oil rigs and the oil companies or the baseball teams or the Premier League soccer teams, once they find out this advantage, usually the market closes and they all implement the advantage, and it's a pretty small advantage at that point. We've already had about 4 or 5 iterations of improvements in baseball, really making a difference in the game, and they've been closed because all teams adopt them fairly quickly. So yeah, it applies to anything. It's just data science, really. And so I don't know how much people are familiar with sort of the fundamentals of data science, but this is just applying data science principles to sports and trying to better understand the game itself.
It sounds like stock market analysis.
Very much, yeah. So arbitrage and financial analytics was huge. There's another great, more recent Michael Lewis book called, I think something like Fast Boys, but it's essentially a technological, sorry?
Fast Boys is correct.
Yes, thank you. But it's a technological innovation. Just faster wiring made you millions and millions of dollars on these trades. And so that's a small, slight example of how you can take something and then win with it. So this works, though. This absolutely works. There wouldn't be 500 jobs in baseball doing this work on the 30 teams. There's only 30 teams in baseball. So every team has a bunch of people doing just this so they can have these advantages.
Andy, as you may know, this group is basically engineers and scientists of one sort or another. So
Okay.
Feel free to say anything you like, except for maybe Fourier transforms.
Okay, good. Very good. Glad to hear that. If you care about this, this is a great
What's
website.
wrong with Fourier transform?
Fourier transforms are fine.
Andy,
If you care about this, I just want to show you this one main
am I
website.
on mute?
No. I'm not sure, Bob.
Uh,
Anyway, sportsreference.com, sports-reference.com is a great website, all covering lots of different sports, baseball, basketball, the NFL, professional football worldwide, hockey. There's all kinds of data here. And I'll just show you a quick, well, we'll do different things. This is sort of a starting point about what some people think about sports analytics. If you're a baseball fan, you might know Joe DiMaggio or Ted Williams. These are very famous, great baseball players who have made the Hall of Fame, are considered, some of the greatest baseball players ever. But there's an argument around which of these players is better. Well, you can solve these arguments. You can go to the data and you can argue the data around these arguments. So let me just poll people. Who thinks Joe DiMaggio was a better baseball player than Ted Williams? Anyone? Well, you're all right, because Ted Williams was by far the better baseball player. But that's, this is one of those things that if you're a Joe DiMaggio fan, you don't necessarily want to hear it. You might think, oh, it's Joe DiMaggio. Chamberlain or Russell, Bill Russell or Wilt Chamberlain. Same thing. You can put this to the test. And people think it's, a lot of people around here especially think it's Bill Russell, but it's Wilt Chamberlain. He was so much better, demonstrably better by data. And then there's Brady or Manning, and this is, again, the kind of thing that gets people upset. But Peyton Manning has better performance numbers than Tom Brady. So these are just interesting ways you can think about it, a broad question that actually generates passion.
Excuse me, but that broad question screams out for a definition.
Sure, exactly.
Right? I mean,
Exactly.
Joe DiMaggio was a better fielder than Ted Williams, but maybe you can show that Williams is a better batter. How do you?
Well, right. No, this is perfect. Great question. So Ted Williams was easily, by far, not even close, the better batter. Ted Williams was probably not as good a fielder as Joe DiMaggio. Joe DiMaggio played a lot of center field, which is a premium position. He played it pretty well. Ted Williams played left field pretty well, at Fenway anyway. And so, these are parts of the game, though. So how do we think about adding the contribution of a fielder to winning versus a batter to winning? And this can be done. You can do this empirically. You can start trying to figure out the contribution of a fielder to winning a game and the contribution of the hitter winning the game. And you can debate this among baseball analysts, as has been done, and you can actually quantify this, and you can come to some agreement. There's a pretty commonly held agreement that it's really not that close between DiMaggio and Williams.
And could you explain this in terms of the VAR, value over replacement? How you would
Right, so it's actually called WAR.
Oh, the WAR, yeah.
Wins over replacement.
Okay.
It is value, it's wins, it's whatever it's all the same thing. It's trying to understand the idea of how a player is better than the freely available player, and that's the replacement player. And this concept here was very important. It's really about 30 years old. This idea of replacement level is the way you should think about the analytics here. It's no different than if you understand economics and margins, marginal values of things. That's what this is to look at the value over what's freely available, and that's what this metric called WAR is, wins over replacement. Now, WAR, that value over what's freely available, is such a fundamental concept in all of sports analytics. And that means I can find somebody somewhere at the lowest possible price and put them on my team. What value do they bring? And then what does Ted Williams bring above that? What does Mookie Betts bring above that? What does Tom Brady above that? So that's the concept. And it really is the correct way to value something, especially in these terms in sports analytics. So you have to understand a replacement player, that freely available thing, the freely available player, and then how to measure the value of any other player above that. And so WAR is really, that concept is so crucial in all of sports analytics. So that's really the basis for a lot of this, right? The basis for DiMaggio, Williams, Chamberlain, Russell, Brady, Manning is that value over the replacement player. And you have to try to measure this as objectively as possible. Okay, you don't just say you wouldn't have this be just a shouting match between fans, a Yankee fan and a Red Sox fan. You want to step back, look at the data, try to understand where value comes from specifically. So just to give the story away, batting value is about 4 times more important than fielding value in field players. So the greatest fielder in the world, who's probably a shortstop for the Los Angeles Angels, his value is this much. If he can't hit, is he really going to be valuable? There's been examples all over sports where they had very good fielding players, but they actually didn't help teams that much because they really couldn't hit the baseball. So this is a fielder, a player on baseball has to do 2 different things. They've got to field their position, unless they're a designated hitter, and then they have to bat in the batting lineup. Then, of course, you've got pitcher catchers on defense also. That's another crucial part to the whole defensive effort of a baseball team. So I made the claim earlier, best baseball player I've seen in my lifetime, and I'm an old guy, Barry Bonds. People don't like that. I say that often in my talks, and people go, Mike Trout. Well, it's demonstrable. You can look at it. The best baseball hitter has been Barry Bonds. Best baseball player overall might be Mike Trout. Mike Trout is already a Hall of Famer. He's a young player still, and he's just extraordinary. As a player, it probably is Mike Trout, the greatest I've ever seen. As a hitter, though, Barry Bonds is a much better hitter than Mike Trout. He was extraordinary, and I don't think people gave him credit for that. They still don't give him credit for that as much as he deserves it. Any other questions?
Doesn't Barry Bonds have an asterisk, though?
Yeah. I mean, I don't know where to put asterisks. I don't know how to do that. I really don't. So do I give an asterisk?
That's like a thumb on the scale, right?
Well, yeah. So how
Well,
much of it
explain.
is,
What's the
key
significance
question-
of the asterisk?
the key question in the asterisk for Bonds is what was the delta of that, his use of steroid? Well, for one, did he use steroids? Two, did it help him be better than the rest? And I'm not sure the data show anything definitive, mainly because I can't say who was on steroids. We don't know. We have no idea of knowing his value added for the steroid usage. It's a too difficult a problem, and we can't recreate the scenario in the data to say, oh, this cohort had it, this cohort didn't, this cohort used this dose. It's an intractable problem, essentially. But yeah, if you like the asterisk, that's fine. I just don't think the asterisk on a player is fair because we just don't know who was using steroids and how that impacted the whole game at that time. It's still true today, by the way. The idea that baseball or professional sports is clean as the white-driven snow on performance-enhancing drugs is a fallacy, by the way. So just so you understand, it's still going on today in baseball and all other sports. It's part of the nature of competition by humans. We look for advantages to win things we want to win. And performance-enhancing drugs are not going away. Sorry. Yeah.
If you neglect the asterisk, then Lance Armstrong was the best bicycle rider ever.
Lance Armstrong was extraordinary. That's true. But they in cycling, they decided all his records are gone. The thing that's pretty well known is that all cyclists in those days were very heavily using performance-enhancing drugs. All of them. You couldn't do the Tour de France unless you were really supported with performance-enhancing drugs, as was Lance Armstrong. Now, he brought it to a science. He took it as a science, and he really improved himself. And lots of great stories about that. But Barry Bonds, bottom line, Barry Bonds swinging a baseball bat is extraordinary, and it's the best I've ever seen. And I spend a lot of time watching baseball. I have the privilege of watching 40 games a year at Fenway Park from the press box, and he was the best. He's just amazing. So anyway, let's get on to some data. Anyone else, any other questions?
Yeah, let me ask an additional question. You're rating individual players against one another, but if you're the manager or the general manager, you're building a team. And then the question is, is there a difference between, measurable, I guess, this difference between thinking you're maximizing your output, however you want to define it, winning games, I guess, by maximizing each individual player or by doing something else? I mean, for example, the order of the lineup and can have an effect on things, and then that depends upon who's there and so on.
No, yes. So that's a great question, because it really is the fundamentals of what happens inside a team's thinking. They've got they have 25 roster spots. That's a constraint. They've got a budget that's set by the owner. That's a constraint in their model building. Okay, they really are going to model how much money do I spend on these? How much money do I spend on these valuable pieces? I've got 25 pieces. Okay, how do I spend the money on them? Where can I afford to get value at a lower cost? Over here, is that going to work? Over here, is that going to work? Where do I spend for value? Okay, so this is modeled. This is actually, it's a great question, because this is what advanced analytics in the baseball team is actually doing. They're optimizing their spending for players based on the market and the cost of all these different players. Okay, so they understand the cost of a Mookie Betts versus a cost of an Andrew Benintendi. These are names, sorry if you don't understand, these are Red Sox players, but they have much different costs and much different value. You throw that in your model and you try to come up with the answer. So every team is constrained by who's on their roster now and what's available now, and then how I can translate what I have, what I need, into what I can spend and the value. So this is all model. Exactly your question is how it's done in real life. Okay, there's many people working for the Red Sox trying to answer your question exactly. Okay, how do you put a value on something? What's its cost? How does it fit in the construction of my 25-man roster, my baseball lineup, my starters? And then it's up to the field manager, okay, to work those 25 people to win a baseball game. So there's acquisition management, the general manager and the baseball analysts over here. They acquire the players. Then there's field management. They do the field management of having those players play the game and win the game as best they can. That's a great question. Anything else? So that's a great segue to modeling.
Yeah.
Oh, go ahead.
Let me ask a somewhat related question. This is the value or expected value, I don't mean that as a statistic, is time dependent, because a player can grow or skills can go down. How is that put in? And
Right.
What sort of time frame do the teams get interested?
Okay, so I think you asked about the different components of a player and their skill set and how that translates into winning a game, their own value. How do you look at somebody's various skills of throwing, hitting, running, and how that translates into their full value? And this is the other part of the study, right? So you really want to measure skill and talent rather than outcomes, okay? Outcomes can always fool us, okay? And this is a principle of anybody doing observational science, collecting data. Data that we collect sometimes looks like performance data, but there's noise on top of that signal, and it's certainly true in baseball. For example, there's years where, Brady Anderson hits 51 home runs. Is Brady Anderson a 51 home run hitter? Is he that kind of player? Well, no, he did it once. It was an outlier. So worrying about these things of performance, you have to get to skill. Is Brady Anderson's skill the skill type that's going to generate 50 home runs is the proper question, rather than, let me get Brady Anderson. He just did 51 home runs. So skill and talent measurement is really the key. This is the key in just about anything people are observing in human behavior, human action, human activity. You want to get to the skills and talents rather than the outcomes. So same is true in baseball. If I got your question right, how do we measure somebody's throwing arm? How do we measure their running speed? How do we measure their hitting ability? That's the key metric we want to use to put value on a player.
Well, no, I wasn't really asking that question, but maybe I should have. The question I was really asking is if you view a player as an investment rather than a something that you're buying for this year, how is that being measured? And Mookie Betts is a better player now than he was several years ago, and in fact, he became much better over one particular year. So how is that brought in?
Right. So Mookie Betts and others, still you want to measure their skills and talents, and you want to put a value on it, and you want to project it out over time. So there is value. I mean, the idea of projecting what's going to happen to a player is really crucial. Projecting is still an important part of forecasting, is really the broader term for it. Forecasting is still an important part of sports analytics. You want to forecast the investment over this amount of time, the cost, so you can do cost analysis and value analysis that way with a projection of what the value is going to be. So it's not just value for 1 year, it's value over multiple years and cost for over multiple years. So that modeling that we spoke of earlier is done both for 1 year and for multiple years. You don't sign Mookie Betts to a long-term contract unless you consider his value for all those years of the contract. And so you do the cost and the value of the length of the contract. What was the recent contract? The Yankees just recently signed a pitcher. This pitcher is outstanding, probably one of the 2 best pitchers in baseball today. So they had to project out, he's 26 years old. How do we reasonably project how many years he can pitch at this highest level? We think it's this much value. And so we can spend this much to acquire that value to help us win baseball games. So it's done long-term, it's done short-term, but it's essentially that the value metric, you put a value on the player, and you analyze the cost of that player. That value cost analysis is what baseball modeling is all about, acquiring talent.
Have you ever seen the kind of data books that slaveholders kept on their slaves, and valuations applied at different ages and different times in their life?
No, that's
it's
fascinating.
very similar what you're describing.
Well,
I don't know.
That sounds a little scary that baseball is in the same realm as slavery, but that's fascinating.
I think the players consider themselves slaves.
Sometimes they do. Yes.
On the other hand, slaves were not paid wages.
Fair enough, but that's a fascinating example. What you brought up is a great comparison to this sort of.
I had a question about hitting a clutch hitter coming up in a big situation. Having watched DiMaggio and Williams for many years, because I'm an older guy, DiMaggio was a great clutch hitter, and you always wanted him to come up in a big situation. So how exactly, you probably do quantify, but how exactly would you quantify that?
Great question. The observation of clutch hitting that you just made around Joe DiMaggio is common. We have to worry, though, about observer bias. Okay, so, and that's natural. Humans do this all the time. And so we have to try to, as an analyst, data scientist, you want to try to get away from observer bias. You say, I want Joe DiMaggio up at the crucial time. My son would say, I want David Ortiz up at the crucial time.
Right.
So very similar observational bias. I'm not accusing you in particular. This is a human condition about our ability to be objective on things we've observed. We have to try to manage our observer bias. So to measure clutch hitting, and this has been done often, it's probably one of the first most important studies in baseball analytics in the early 70s. Actually, it started. The first study was to try to measure this idea of clutch hitting, okay? Can you find players who actually perform better in what you define as a clutch situation over the rest of the players, over their normal behavior? So you've got to take Joe DiMaggio and who he is. Does he actually, is there any data showing that he performs better in these higher leverage situations than Joe DiMaggio normally does? Does he have that innate or conscious ability to say, it's clutch, I better be better now than I normally am? Okay, so that's how it's been defined in analytics. Can you measure situation? Can you measure a player that putting themselves in a higher leverage situation consistently outperforms what they normally do? So does that help as a definition? I mean, that's what that's what clutch analytics is all about.
Yes.
And it turns out when you do these studies, most of the time you can't find it. I mean, literally most of the time. There are some studies that show, oh, wait a minute, I did it this way and I showed this effect. So it's not like a lot of science. It's not black and white. It really isn't. And I don't want to portray it that way. But the vast majority of the science shows that when you look for this ability in a high leverage situation where you have enough sample so that you get real signal as opposed to just the noise that would be there. When you get the signal of the delta with enough sample of high leverage to what they normally be, you can reliably say that they would be as a player. Sometimes you see it, but if you see it when it's seen in these studies, it's such a small effect, okay, that it becomes almost, okay, yeah. So one of the better studies done showed Tino Martinez of the Yankees was the first baseman. He performed better in clutch situations. It was a really good study. Lots and lots of data, a whole career's worth of data and analytics. And you could see Tino Martinez was slightly better in clutch situations than his normal Tino Martinez self. So everybody said, oh, clutch, it works. But it's nowhere near what our observer bias tells us. The effect was very slight when you did it objectively.
But I would have thought that, the clutch issue would be, does he stay calm compared to somebody else who actually does worse in a clutch situation?
That's a great point, Charles. I'm reading your name. I don't know you, Charles.
That's pretty good. Charlie works too.
Charlie, okay, so that's a great point. That's really crucial. Like in any science, we want to look at that. Like, oh yeah, what's the cause and effect? Is it real? I observe it. What's going on? Well, the way it's argued in the literature, and believe it or not, there's baseball literature. I mean, I know this sounds odd, but the way it's argued in the literature is that when you really look at the sample of baseball players we care about, they've already gone through the selection process. There's a highly selective process to choose these people. Now, there will still be people who play professional Major League Baseball who are not as calm as others, okay? But they don't play that much. The selective pressures, in a real Darwinian sense, the selective pressures are so against having people who are not calm in the batter's box. Like if we took our sample of us right now, we went to a batter's box and we actually faced a 98 mile an hour fastball and that hammered curve coming at our heads in the batter's box, we would not be calm. It would be terrifying for all of us. Okay, it would. but we're not part of the selective process anymore to get to that point where we can do that. We can hit that baseball being thrown by that talented pitcher. The selection, the Darwinian selection, is against being twitchy like us, being scared like us. You select for the calmness. So as you select for the calmness, all you're going to be, success requires that you can see that pitch. Because if you can't see that pitch and you're frightened of those pitches, you're never going to hit. So we've already selected for people who are already intentionally calm. Now that's not 100% true. Not every person. There's a spectrum here, obviously, of the most calm and the least calm. But that difference between the most calm and the second most calm and the third most calm bins of baseball hitters, what you see is there's really not much difference in what they do in these different situations. But yes, you can obviously create the scenario where you don't perform well in the clutch. But we're selecting for that. We're selecting already for players who perform well in the clutch. If that makes any sense.
Hey, Andy, just
Andy?
as a piece of trivia, would you remind us how many milliseconds it takes to pick up a pitch so that you can decide what you're going to do?
Yeah, the length of the pitch is anywhere from about 400 milliseconds to 450 milliseconds. That's the length of the pitch from the pitcher's hand to the catcher's mitt. Okay, so you got 400 milliseconds. You've got about 1/3 of that as a batter to decide. So call it 150 milliseconds. I'm waving my hands, but you have 150 milliseconds as a batter to decide to swing or not. And then you've got to execute the swing in the last 300 or so milliseconds. You've got to execute that swing with your muscles and your skeleton to try to hit that ball. Okay, that's just the nature of performing in the major leagues. It's different if you're playing softball, or different if you're playing, kids are playing against kids, or old guys are playing against old guys. Any of you play old guy baseball in this audience? Real hardball. Yeah, it's fun. I still play old guy baseball. We're not as fast as we used to be.
Andy, this is Bob.
Hi, Bob.
I wasn't going to comment on this, but I think clutch hitters are better at adapting to pit. They guess better and they adapt better to what happens. Having watched Clemente play a fair amount, you couldn't get the ball by him, and he couldn't have been guessing correctly every time. And Sanguillen on the same team didn't seem to matter what you threw him. But actually, my question was, what's your reaction to this? Because I think the game is about wins per dollar, not absolute wins. And the example I keep thinking of is a Moneyball example, Oakland versus a team spending a lot more money. So I was wondering your reaction to this. And final analysis, I think when you get to the next to last and last round of the World Series, you run into the problem that whoever gets there is going to have, most of the teams are going to have a high payroll, which buys you at least 2 stud pitchers and 3 or 4 batters that can hit stud pitchers reasonably well. And the problem Oakland has, and any team trying to do it for, say, 40 million instead of 200 million, is that their batters degrade more or less gracefully against those stud pitchers than the batters on the other team who can hit those stud pitchers. Because I've tried going in a stud pitcher. A guy can throw 5 or 6 pitches with control. What's the Red Sox have had a couple recent. Warren Spahn. The guy's still
Spahn was
coaching.
Braves, wasn't he?
Coaching for
the Braves. Pedro Martinez was that.
That's the guy I was trying to come up with. Pedro, who could control an off-speed pitch that would break 2 feet. It was just astonishing, and he was unhittable almost. So And it seems to me metrics get you so far. Like, obviously, Oakland applied them very well. But you're still going to run into the owner willing to spend $200 million, who's got, and you're not going to win every time with those studs, let's call them, but the odds are heavily in your favor. So I was wondering, I mean, it may be obvious that spend $200 million, you're probably going to do better than $40 million. But so what's your reaction to that
So
analysis?
Yes, baseball is not a fair game. This is not I would call a coin flip a fair game. Okay, it's a 50-50 outcome. Baseball is not. Teams with more finances to spend on talent are going to be better teams, as a rule. Now, the way you work this though is you work within the constraints of your budget, and so you have a budget. The budget for the A's versus the budget for the Yankees is unfair, period. You're absolutely right. It's just unfair. But the A's with the lower budget are still going to try. And they're still going to try and do well. I have had 2 former students work for the Tampa Bay Rays in the analytics department. And they have this constraint you're talking about. They really have a budgetary constraint. They can't sign the most valuable pieces because they cost too much. But they still are going to try to win the game. And even though they admit right up front it's an unfair game. It's unfair. It's not fair at all. The Yankees and Dodgers have advantages so far beyond what the Tampa Bay Rays have. But they still show up. Tampa Bay still shows up, and they're very, very happy when they win. They have a great organization and a great team. One of these days, Tampa Bay is going to win a World Series. And it's going to be a great day for this small market team that is unfairly playing this game against someone else. It really is a stacked deck at the start against. So just so you know that, baseball people know this. It's the constraints of what the owners want and what the players want and the way it's been set up. They don't want to make it fair. If they did, they'd make it fair. They just don't. Okay? So there's other business motivations in here. Running a business, making money, that are driving these kinds of decisions. But it's not fair at all. It's not fair at all.
Why doesn't the Major League level the playing field and have financial constraints like the NFL?
Because I think they've decided. I think they've decided that it's better for them financially to do it this way. And
the big market teams decided it was better for them financially.
Yes, but in general, I'm not an economist, okay, so I'm speaking like I know something that I don't know. I don't know these things, but I've tried to study these notions of trickle-down economics, these ideas of things trickling down. And look, I don't know anything about it, but I do know the Rays get advantages from the Yankees being in the league. Okay, they do. The fact that the league has this unfairness actually enhances the whole league's revenue. And the Rays know this. Do they want a level playing field? Sure. I think the analysts and the general managers and the players do. But there's another component here about their revenue and their revenue sharing that they kind of want these big revenue clubs around too. The NFL chose a different model. They've chose this idea that we're all 32 teams are going to be, the same on the same salary cap. Is it fair though? This is just a general question. Is it fair that the Patriots have the greatest general manager of all time running their team? Is that fair? No, it's not fair. Bill Belichick is special, and his specialness has made lots of money for the owners of the Patriots. Is that fair? Should Bill Belichick be shared by everybody? Yeah, in a certain way it should be, but it's not. This is competition. And so, yeah, the Yankees don't want, they love printing money, just like the Red Sox and the Dodgers and the Cubs do. Those teams love printing money because the owners are happy. But the Rays make a lot of money too. They just have a lower budget. And they like the idea of it being in the league with the Yankees, so they're happy with that. If this isn't clear to folks here, and this might be going to YouTube, so I'll get slammed if someone watches this, but this is essentially true.
Andy, can I ask a different question?
Okay, sure.
The other side of the...
Jerry, before we go down this rat hole, I just want to do a time check. It's 11 o'clock. We have a half an hour. I don't know how much time you have left on your presentation, Andy, and I don't want to go down a rat hole that's not going to allow you to reasonably finish.
Okay, yeah. Trust me, like I said, I've got a lot to cover here. Bottom line, the unfairness of the game, I think, is embedded in the structure of the game, and the Rays don't mind it because they make a lot of money. The Yankees don't mind it because they make a ton of money, as do the Red Sox, Dodgers, Cubs, and others. So, yeah, go ahead, Jerry. You got a question?
Yeah, on the other side of the equation is observer bias, which you actually didn't define.
Oh, right.
And if I say the word, for example, observer bias, and I say Kirk Gibson, everybody remembers one swing. They remember limping to the plate and taking one swing. And he became a great player for people. He was a West Coast player. He became a great player nationally on the basis of one swing. So what is observer bias?
Well, observer bias is the idea that we've observed something. Well, observer bias, by definition, is when the observer comes in and observes it and changes the situation. But what I mean by observer bias, and I might be getting the term wrong specifically. I have to go back to my my rhetoric classes. But what I should define it better. My observer bias is the notion that I should say, you know what it is? It's recency bias. I was confused. Recency bias is the idea that I've seen it more recently, and then I think that's the true ism. So I have recency bias when I see Joe DiMaggio get those clutch hits and David Ortiz get those clutch hits. So I think David Ortiz is clutch. It's my observation. But it's biased by what I've seen and not necessarily an objective sample of the whole thing. So you're right. I take that back. I should have chosen my terms more carefully.
And is it quantifiable?
Yeah, well, it's quantifiable by objectively defining what you mean. So
No, in terms of my decision making. If I have observer bias, how does that affect my decision making?
you've got to realize it's there. And you've got to try to create enough sample so that you actually start measuring signal over the noise, understanding what's noise and signal, and how your sample actually gets above the noise, so you're actually measuring what you really need to measure.
Well, is it important in baseball decision making?
Yes, absolutely. It's important in any decision making to understand the signal and the noise, what you're measuring. Going back to measuring it, you've got to understand what you're really measuring. And that's why when the clutch question came up, I defined it as the idea of here's the work of a player. Let's tease away into two groups the work of the player in non-clutch and clutch situations and see if there's a difference within the player, and then look at tons of players to see if there's something there. And you do see it occasionally. Like I said, you see it occasionally, but that's to get at the signal. The actual signal is, what do you do in a higher leverage clutch situation versus what you normally do? So that's the definition.
Andy?
Yeah.
I'm looking at the title of your slide, Baseball Modeling, and we're talking about your biases. And bias is, and clutch bias and recency bias and those other things. They're legitimate variables in terms of modeling. Looking at it from a data analytics perspective. I'm putting on my big data hat. So those are all reasonable things. But the difference that I don't think you're talking about is the weight. And that, yes, recency bias is a variable that you have. And, the observation bias is another one that you have. And there are other things too. For example, personality in terms of marketing, because we are in a business, et cetera, et cetera. But if you put little weight on them, the model will be the model. It's like anything else. When you model something, if you put high weight on a random event, you're going to get the wrong answer, quote unquote. You have to look at the weights that you put on different variables in order to get something that is in fact reasonably quantifiable and reasonably comparable.
That's right. Yeah, I agree. I wish I'd said exactly what you said, because that's perfect. That's exactly right.
I'll send you the transcript.
Okay, good. Good.
Do you have any data about some of the old players such as Babe Ruth, Ty Cobb, Lou Gehrig, how they fared relevant to the newer players?
Yeah. Well, it's all relative, right? I mean, we have fundamental problems comparing Gehrig, Ruth versus Barry Bonds. Okay.
At least we know chances are they didn't use steroids back then.
Well, there's pretty good reports of Babe Ruth seeking out the testosterone-laden meats he could find and food he could find. No, I mean this. It was sort of a thing at the time, but there's nowhere near as sophisticated performance-enhancing drugs of Barry Bonds' time versus Babe Ruth's time. Completely different. There's evidence Babe Ruth tried to do the same.
Andy, how would they compare, as an example, Babe Ruth and Barry Bonds?
Let me do this. I have a slide on that.
Okay.
I have so many slides. I'm so sorry. We're really going slowly here, but here. So this is how you do it. This is Bonds and Ruth, and that's actually Bonds at Fenway, if you can sort of check out the background. But that's Ruth at Fenway. So one of the key things here is their sort of lifetime achievements. If you look at this, there's a lot that's pretty amazing. Anything in gold here, you can sort of see. I don't know if my cursor shows up when I do this, but this is intentional walks. Barry Bonds' intentional walks are ridiculous. It's a ridiculous number. We're never going to see this. This is incredible. So the second, one of the top 3 baseball hitters of all time only had 113 intentional walks. That's crazy. But then you look at other data. You look at home runs. Barry Bonds has some more. You look at number of walks. Barry Bonds is the greatest of all time. Most home runs, this gold shaded is most all time out of all the sample of all time.
Website.
Oh, okay.
So, but these are such important numbers: slugging, OPS, and OPS plus. Babe Ruth is the greatest ever on OPS plus. Mike Trout, who is considered today to be the greatest baseball player playing today. Mike Trout's best OPS plus ever was 198. His best season ever was a 198 OPS plus, and I'll define it in a second. Babe Ruth averaged 206 OPS plus. It's a ridiculous number.
Andy, what is OPS?
His OPS and his OPS plus are ridiculous. It's the greatest of all time.
What are they? What are they? What is OPS? It's an acronym for.
If you look at on-base percentage here, 474 for Ruth. On-base percentage is walks and batting average, essentially adding walks to batting average, getting on-base average. So he got on base at a clip of 47%. Slugging is singles, doubles, triples, and home runs weighted 1, 2, 3, 4 over your at-bats. Okay, so that's a metric of sort of how hard you hit it. He's got the highest OPS of all time. I mean, slugging of all time, 690. That's the highest career slugging of all time. And it's essentially a power metric, how many home runs, triples, and doubles you get relative to a singles hitter. So when you add OBP and slugging together, and you can see the addition, you get OPS. OPS is the sum of slugging and on-base percentage. Not a great metric, but it really is simple. It's actually a relatively simple number that tells you a ton about the value of the hitter. Hitting is essentially getting on base and not making outs. That's OBP. But it's also hitting it hard. You don't want to just get a bunch of bunt singles, and you want to hit it hard, hit it far, and generate a lot of runs, do some damage.
Do I assume the top row is Ruth and the bottom row is Bonds?
No.
Oh.
Bonds is top. Ruth is the second row.
Ruth is the second one?
Yes.
Oh, okay. Thank you.
Yeah, but this 688 here is what I was talking about. That's Barry Bonds' intentional walk. But 206 is basically, this number OPS is just a number. It's a weird number. But relative to your league that year, they take the league average, they make it 100 for OPS. And then your OPS relative to the league, it's a normalized OPS. So we actually can compare OPS to OPS. Oops.
Yeah, but one of the things you say, and in trying to compare people in different eras, is that the average skill level in the league may have been different. For example,
very much.
You know,
one of the biggest problems here.
There's a much bigger variety of pitches that the contemporary hitters have to deal with than the hitters in the 20s and 30s.
The biggest problem comparing these two is that Barry Bonds played when it was a worldwide game. The talent was acquired all over the world. The talent playing baseball in Babe Ruth's time was white Americans, and that was different. So it's a little different sample. We have a sampling problem here of who's being chosen to play the game. And you're right, the technology has completely changed. Look at the baseball mitt in this GIF of Babe Ruth. That's what they played with. They played with different bats. They played with different clubs. They played with different baseballs. They played with different training techniques. They played with different, now we have a lot of analytics. A bunch of nerds like me study this, and we figure out what to do. We figure out how to pitch specific batters in specific counts now. There was no sense of that, really. Now we have objective data that we know how to pitch this batter at this count. This batter has been set up for that fastball high and inside. Let's do it. Boom, and it works. The objective nature of data, the objective nature of decision-making in baseball is ridiculously different today than it was in Babe Ruth's time.
Can you presume, Andy, that the bat that is currently used has a little more bounce than the bat that Ruth used?
Probably very slightly, maybe. Okay. The bats, though, the coefficient of restitution of these different wood sources is essentially the same. Okay. I mean, now I could design a bat, and you've probably seen this if you've watched baseball a while ago. You could design a bat with a huge trampoline effect. Okay. Huge coefficient of restitution, like a tennis racket. A tennis racket is higher number here. Bats don't generally have a decent high rep core, COR, but they are different because what's happened is Barry Bonds and others started using maple. And maple was just it shatters more, but it seems to be slightly lighter as a wood with a very similar coefficient of restitution. But bat studies have been, the physics of bats has been studied. There's no doubt the bats are better today, okay? But wood is wood, and it's got a certain specific, the coefficient of restitution of wood hasn't changed over a century. The different types of wood have slightly different trampoline effects, but it's really not as significant as, say, a bat we could design in aluminum or metal or carbon. Those bats have high, really amazingly high trampoline effects, and you can hit the ball far.
Andy,
Andy?
two quick
Also
questions.
notice, Andy, that Bonds played about 400 more games than Ruth.
Is that right? Yeah, Bonds played more.
286 and 2503.
Yeah, that's correct. Bonds
And-
played more. Yep, and he had more plate appearances. A good 2,000 more plate
And he
appearances.
was there much difference in the baseball in the two eras? And also, when did night baseball become common? And I'm sure Bonds played a lot of night games.
He did.
Does that affect?
I think.
I'm sure you could compare night and day performance.
Yeah, I don't know the night effect much. I don't think people have studied, but it is a more recent thing. That's more. I think the first games under lights were, amateur games near General Electric or something like that in somewhere. But the Cubs were the last team, right? When did they finally get lights? 30 years ago, So, but I'd say the 50s and 60s is when lighting became pretty common. So Barry Bonds played a lot of games under the lights. I'm not
does
sure
it have
there's
an
much
effect?
nighttime effect on these things. It's a good question. I just don't know.
And the baseball, wasn't it wrapped a little tighter in modern era than?
Yes, definitely was. The big difference was, in Babe Ruth's lifetime, and you saw an increase in home runs because of it. There was a huge effect in 1919, in the middle of Babe Ruth's career. Unfortunately, a man died on a baseball field. His name was Rex Chapman in 1919. He got hit in the head with a baseball. He couldn't see it. What they did before Ray Chapman was not replace the baseball. They played with the same one until it got really green and dark and brown, and you couldn't see it by the end of the game. And it was mushy. It had been mashed by the end of the game. That effect in itself was one of the reasons Gehrig and Ruth started hitting so many home runs right after that. They replaced the baseball because of Rex Chapman. So one of the big reasons you don't see a lot of home runs before 1920, people think it's Babe Ruth, and yes, he was a monster. He was just a great baseball hitter. But the other part was the baseball being replaced, so it was fresh, and the technology of weaving and making the baseball today is much different, much tighter. And that's changed over the years too. One of the things you really want to study as best you can is the changes in the actual manufacturing and the coefficient of restitution of the baseball itself. So you got the coefficient of restitution of the baseball and the bat. That impacts bat and ball flight for sure. And one of the big studies, there's been a home run increase, if you follow baseball, home run increase in the past couple of years, and trying to understand that relative to batters' approach, how they're trying to hit the ball, and also the baseball itself has been very interesting if you follow baseball.
Andy, we have, I don't mean to push, we have about 15 minutes. Is it possible to take everything you're saying, which has been really interesting, and go through an example on how we evaluate a player or make a decision as a sample exercise? Yeah,
Let's. I don't think I have the slides. Let me just describe it. There's something called catcher framing. Okay, this is a Moneyball market inefficiency. Okay, so the Tampa Bay Rays, my student, the reason I can talk about this reliably is I've had my student come to my classes and tell this story. So they figured out this idea of framing. The idea of framing is that if the catcher can steal a strike when it really was a ball. The ball is the pitch is outside the strike zone. The pitch comes in, it's a ball, but the catcher has a skill to fool the umpire and make it a strike.
Yeah.
This turns out to be a skill that some people really had. And, people knew this. People knew there were good catchers and bad catchers. And people understood, sometimes they steal a strike or they don't. But what the Rays did 10 years ago, 8, 9 years ago, about 10, let's call it 10 years ago, they started looking at this objectively. And they saw that it's actually so much more important than people thought. And there really were talented players, catchers, who consistently kept stealing strikes better than others. There were catchers that used to just be we call them backstops. You know, they essentially should just stand there, let the ball hit them in the chest protector, drop it, and pick it up and throw it back. They weren't doing anything to try to fool the umpire. So they were really hurtful to a baseball team because they never stole strikes. But the players who could actually steal those strikes from the umpire were worth about, and this is way back then even, worth about $20 million a year when I boil it down to the actual value. The dollar value of that player doing that thing. And you could buy these players for cheap. Their value just because of their catching was well over 3 wins a year. 3 wins a year just from catching it smart. The Rays couldn't believe it when they found it out. They put 4 or 5 people separately on the same problem and said, measure this. And once they realized that all the results were coming out consistently the same, they started signing these catchers for nothing, the lowest salaries possible, who would just steal strikes. And they had this advantage for like 2 or 3 years. And then finally somebody somewhere, I don't know how it got out, but somebody else did the same study. And before you knew it, the whole industry understood this very clearly, that you actually steal strikes with good catching. And all of a sudden, catchers were never signed again. Certain catchers were never signed again. And now catchers are specifically in this lane. You can't be a major league catcher unless you're framing well. So it changed everything. So now coaches who coach the youngest players who might have a chance to be a major league player, coaches who coach the elite players all over the world who might have a chance to be a major league catcher, they're all trained in how to do framing well. Okay, so for example, I'm trying to think of the Red Sox. If you follow the Red Sox, the local team here, we have a very fortunate catching situation because there's a young man named Christian Vasquez who is an unbelievably great he's an unbelievable great framer. He steals strikes all the time. But what's happened is, so there was a huge market inefficiency between what the Rays knew for a couple of years and what no one else knew. They got extreme value out of these catchers where no one else understood it. And then slowly that market inefficiency is very small now. In other words, the difference between the best catcher and the worst catcher in baseball in their framing ability is very small, where before it was very wide because it wasn't well known. So that's a story of an analytically driven market inefficiency taken advantage of by a team, but then once it's widely known, that market inefficiency closes. And the game is changed because now there will never be a catcher in Major League Baseball who is not very good at this important skill.
Well, why wouldn't you change the technology so that the strike is truly a strike and you know it? Why not?
That's a great idea.
Why not get rid of these guys? I mean, it sounds like cheating to me.
Well, your cheating is someone else's market inefficiency.
Well, as long as they can get away with it, they don't consider it cheating.
Well, as long as it's not against a rule or something, right? You know,
Was it
there really was a market inefficiency that was closed because everyone else understood it finally.
At this point, they'll start calling balls and strikes by computer and DAR and all the rest.
No,
all those issues.
Here's a wild prediction, and you come at me in a couple of years. Within 2 years, it's going to be announced we have robot umpires in Major League Baseball. That's a crazy prediction, but it's going to happen. So, you know, what you mentioned there, Charlie, is
is
likely to happen. We will have robot umpires. And that means
Yeah.
At that point, the catcher's skill set around framing is worth zero value. It's done by a robot at that point.
I just want to see the altercations between the players and the robot.
Right. No, but
It's consistent. As we know now, different umpires have different ranges of height and width that they use.
That's another great transition that's happened over time. Years ago, I'm looking around the room. You're all about my age. We're all gray hairs, and we're all old baseball fans, maybe. Years ago, umpires really had different.
You're a young guy.
Umpires had real different strike zones. In other words, it was like just part of the game. One guy was very different than the other guy. But then they got very consistent. Once they started getting reviewed, once they got the technology to say, here's how many strikes you got wrong, here's how many balls you got wrong, umpire. Once they started getting reviewed and their bonuses and their salary started depending on how well they called the strike zone, it's amazing how quickly strike zones got very consistent. So today, even though you're right, there's a difference among umpires. It's very slight compared to what it was 30 years ago. 30 years ago, umpires had personalities and characteristics, and, they would be like, any high strike that they'd call it. It was just like a thing that umpires had certain kind of ball strike calling tendencies that were extremely consistent within themselves, but very different from one another. One of the reasons they don't announce an umpire these days is for gambling. They don't announce the umpire at the start of a series for a lot of games until the last minute, because if you understood who the umpire was years ago, it could be you could really understand how run scoring might be affected. Because if you have a big strike zone, less runs, small strike zone, more runs, and players knew this, pitchers knew this, and it really you can measure it very. Gamblers and analysts used to know how to measure this and take advantage of it because it was a nice inside bit of information that you can leverage into your betting scheme.
Andy, do you think catchers paid attention to which umpire they got? Because some of them on TV look to me like they're more susceptible to framing than others.
I think that's right. I think there are four on any pitch. This is going to sound crazy, but on any given pitch, and modern analysts know this if you work for a team, on any given pitch in baseball, there are four strike zones. There's the pitcher's strike zone, there's the batter's strike zone, there's the catcher's strike zone, and the umpire's strike zone. And they're all different. They're all consistently different. I can look, let me see if I have included any slides of this. No, not in this deck. But I when I talk about this, different ways, let me put this slide up. This might be interesting. When I talk about this different ways, I always do try to show these different strike zones. I can show examples of an umpire strike zone and how they're different, batter strike zone and how they're different, catcher strike zone and how they're different, and then pitchers and how they're different. So the analysts understand this. They know when this umpire is going to be umpiring, or this pitcher is going to be pitching, or this batter's at the plate. They understand much, much better how they work together. Oh, by the way, this is one of the most seminal and important books in all of baseball analytics. But it was written by Pete Palmer, who's a wonderful, wonderful, wonderful man. I expect some of you know Pete Palmer. Pete Palmer lived in Lexington, worked at DEC for years, and now lives in New Hampshire and Florida. Does anyone here know Pete Palmer, Lexington resident? No, it's too bad. He's such a treasure. Anyway, I just thought I'd mention that.
What is all the numbers and the math they're showing?
Right. So this is a formula called linear weights formula. And this is Pete's contribution to baseball analytics, which is unbelievably seminal, and it's the Mount Rushmore formula for baseball analytics. And Pete put this together. And basically, there's events here that happen in a baseball game. And so 0.46 times 1B, that first term there, is the run value of a single. When you measure all of the times a base hit, a single happens, and you add the impact of that event on run scoring in a baseball game, that's the right contribution. This is the average contribution a single has to a run. And that's what all these terms mean, the 0.8 times a double. You hit a double, the average double adds 0.8 runs to your offense. A triple adds 1.02. Now, you have negative terms here. Anytime you get caught stealing, it actually harms your run scoring environment. Anytime you at-bats minus hits is outs. Anytime you hit an out, it decreases your run scoring environment. And anytime there's OOB is other on base, anytime it hurts. So this is a really important formula. Some of the key takeaways here are a single is not the same as a walk. Okay, and that's represented in this formula. The single is 0.46 times 1B. The walk is represented as 0.33 runs times a walk. So a single is more valuable than a walk. So the aphorism, is a walk is just as good as a hit is actually not true. The other interesting thing here is SB is stolen bases. It only has half the value added as the caught stealing has the value subtracted. 0.6 is a term for caught stealing. So making it out is really bad on the base paths.
So that's, you've got to have a 2-to-1 chance of making the stolen base successful.
Exactly.
Make it
Exactly.
work.
So if you have a success rate of stolen bases of 4 out of 5, you should steal, depending on the right situation of the catcher and the pitcher and everything else. So again, the pitcher, the catcher, and the base runner all have an influence on the probability of getting a successful steal. So that is exactly what the baseball analysts have done. They've looked at the pitcher's contribution to the stolen base, the catcher's contribution to the stolen base, and the runner's ability to on average, to steal a base. So
why the number of steals is way down?
That's because people understood it's not worth the risk. It's exactly why. Teams understood it's not worth the out to just say to risk sending somebody. It turns out if you know Earl Weaver, some of you, if you're baseball fans, you might know the name, but Earl Weaver was right. Let's hit home runs. Let's not worry about bunts and, let's not worry about stealing. Let's hit the ball hard. And he knew that 50 years ago, and he wrote about it. Great book. And turns out to be right.
Andy, the rules of baseball allow analytics to be used real time in the game?
No. The only data, you can have data, but can't be updated in real time. So you can walk into the dugout with a folder full of printed out worksheets or an iPad with data on it, but it's not connected to anything in real time. That's the rule of baseball today.
So even if it's a powerful iPad that can do these analytics pretty quickly, that's legit, but you can't have it going back and doing quantum analysis?
Right. It's legit to have an iPad not connected to the world. It's got to be an isolated iPad, it's like a folder.
How can you enforce this? A guy
if you followed the recent scandals in baseball, it's hard to enforce.
Yeah.
Okay. So the Red Sox, Astros, and Yankees are in trouble because of this tough enforcement.
And you got to take away garbage cans.
I'm sorry? I missed that.
And you have to take away garbage cans.
Yes, garbage cans as well. Yes. No, it's really hard to enforce. It's a great question. But the technology is easy to enforce. You just have to make sure that iPad. There are major league employees roaming around dugouts and hallways to the clubhouse. And they're going to be, because of the scandal, they're going to be probably many of these folks really checking better, trying to enforce this better. But it's really, really hard to enforce. One team bought a Cray supercomputer to help real-time analysis. Okay? Their model got so tricked out with such important information that they threw everything at it. And they wanted it to be so quick, they bought the Cray so they could do real-time analysis for this reason. But you can't really use it during the game. That's by rule. Who says, there's teams that are always trying to do that. I mean, everybody's trying to get an advantage to win these games. So, how are we doing on time? Any more questions? I'm so sorry. I got through about 10% of my slides. I apologize.
There's always the opportunity to come back.
If you want me to come back, just ask. I'll be glad to. This is a fun conversation, and I like to hear your questions.